Let's do an example of doing a hypothesis testing for two population means. Let's say we would like to do an example of two different methods of doing a review for online or for the math portion of the SAT. We have a face-to-face class and then an online class. And what we're going to be doing is randomly assigning people to the face-to-face class and randomly assigning people to the online class. After we give the face-to-face class some lecture material and a semester, we're going to have them take the math portion of the SAT. So we had a sample size of 40. They got a mean score of 570 and a sample standard deviation. The standard deviation of their sample was 90. Another group of students did an online class where they reviewed for this, and they had 50 students in that class, a mean of 540 when they took the SAT, and a sample standard deviation of 100. Now, the research question at the .05 level of significance: is there enough evidence to conclude there is a difference in the average scores of students using these two methods? Now, it's true that the people in the sample, one had 570, one had 540, but we're trying to come to a conclusion about the population. Everybody that would use the face-to-face, everybody that would use the online class. Okay, step one, null and alternative hypothesis. We're going to start out by assuming the means of both populations, the means of students that use both methods, are equal. The alternative is not equal to, and that's because we used the word difference. We were interested if one was bigger than the other or vice versa. The critical z-values, well, with a level of significance of .05 and a two-tailed test, your critical z-values are 1.96 and negative 1.96. We'll reject the null if we get a value above 1.96 or lower than negative 1.96. This is the group of formulas that we'll be using to calculate the z-value. We're going to take the first sample mean minus the second sample mean divided by a standard error. And this standard error is going to be found by taking the standard deviation of the first group squared divided by the size of the first sample plus the standard deviation of the second group squared divided by their size of the sample. So then you're going to add these two independent computations together and take the square root. In this case, the sample mean was 570 and 540. The standard error was 20. And we end up with the z-value, a calculated z for the difference between sample means, of 1.49. As you can see, 1.49 is going to fall in this area, not quite reaching the 1.96 area. Therefore, step 4 is going to be do not reject the null hypothesis. And our conclusion is going to be that the mean score of students being taught using face-to-face instruction could be equal to the mean score of students using the online method. We simply don't have enough evidence to support any other conclusion without having a chance of making a type 1 error of greater than 5%. So we conclude the mean scores could be equal.